I'm going to start this lesson on percent composition by doing a few review questions on percentages. The word percent means per 100. If a basketball player makes 32 free throws every 50 tries, what percent of his free throws has he made? We can set this up as a proportion of the shots that he makes over the tries and set that equal to something over 100. 32 are the shots that this person makes, and 50 tries equal to sum over 100. I'm sure you've done percentages before where you divide the part by the whole and multiply by 100. This is that same thing. I'm just setting up as a proportion so you can see that what I'm really doing is making a ratio. I'm looking for the ratio of 32 to 50 and trying to figure out what is that ratio over 100. So if you do this math, 32 divided by 50 and then multiply by 100, you'll get 64%. That is their free throw average. What is 40% of 70? Again, we can set this up as a proportion. 40% means 40 out of 100. I'm trying to find out what is that out of 70. It would be like saying you got a 40% on a 70 question quiz. How many questions did you get correct? 40 divided by 100 times 70 is 28. Last question. If you got 60 correct and 24 wrong on a test, what percentage did you get correct? As you all probably know, in order to know what your percentage on the test is, you need to know the total number of questions. If we add 60 to 24, because that's the total amount of questions, we get 84 questions total. You got 60 out of 84. What is that out of 100? That's what you're looking for when you're saying you get a percentage on a test. And this would be a 71.4%. So now we're going to look at questions regarding percentages in chemistry. We're going to apply some of the same ideas as we were doing above in percentages, but now we're going to do it in a chemical sense. Suppose that a mixture contains 17 grams of copper sulfate and 12 grams of sodium nitrate. What percent of the mixture is made of copper sulfate? Just as our question above, in order to find the percentage of copper sulfate in the mixture, we need the total mass of the mixture. In order to get the total mass, I first must add them together. So 17 grams of copper sulfate plus 12 grams of sodium nitrate gets me 29 grams total. I'm looking for the percentage of copper sulfate over the total. How much copper sulfate is that if it was 100? And the answer is 17 divided by 29 times 100, 58.6%. So now let's look at percent composition within a molecule. Suppose you had a compound that contains 48 grams of carbon, 32 grams of oxygen, and 6 grams of hydrogen. What percent of this compound's mass is carbon? Again, in order to find out what percent of the mass is carbon, you first need the total of all of the masses put together. So if we add up 48 grams of carbon and 32 grams of oxygen and 6 grams of hydrogen, you'll get a total of 86 grams. Then, in order to find the percent that is carbon, we have to use the amount of carbon that we have. 48 grams carbon over 86 grams total. We can set that equal to x over 100. And if we do the math here, we'll get 55.8%. So let's apply that again, but now instead of giving you amounts, we'll use the molar masses. In the compound C5H9O3, find the percent composition by mass for each element. We're looking for 3 separate percentages here. In order to do this, we first need the total mass of our substance. The total mass is the molar mass. So pause the video here and see if you can calculate the molar mass. The molar mass of this substance is 117 grams. Did you get it? Now let's do one at a time. The first element that we're going to do is carbon. If you add up all the carbon that we have, which is 5 carbon atoms, that is a total mass of 60 grams. 60 divided by 117, which is the total mass, is equal to x over 100. If you do this math, you'll end up with 51.3% carbon. I've shown you how to do carbon, so pause for a moment and find the percent composition of hydrogen and oxygen. When you're done, come back for the answer. The percent hydrogen is 7.7%, and the percent oxygen is 41%. And if you add these three numbers together, you will get 100%. All right, so that's all I'm going to show you problem-wise in your assignment, and you'll need to do the rest on your own. But before that, I want to give you a little bit of information on this word in number 7, and it'll also help you with number 5. In chemistry, you can have something called an empirical formula, and that is different than a molecular formula. Let's say, for instance, we had NO2 versus N2O4. These are different molecules. However, they have the same ratio of one atom to another. In both of these formulas, it's a 1 to 2 ratio. 1 to 2 ratio. The molecular formula can be simplified down to the empirical formula. The empirical formula is the simplest whole number ratio of the elements, whereas the molecular formula is the actual whole number ratio. It's a multiple of the empirical formula. These often exist in chemistry. So in number 7, when it's asking for the imperial formula, there are multiple formulas that you can get with this ratio. This is asking for the most simple form of that ratio. And you'll see something similar in number 5. You should think about that concept and see if that applies when you're trying to solve for this problem. The next bit of information that I want to say about 5 and 7 is that you should assume that it's out of 100 grams. So let's say I had a formula that was 30% nitrogen and 70% oxygen. Without anything to go off of, this can be a little challenging. What you can do is multiply it by 100, assume that it's 100 grams, and that will get you to a gram amount. 30 grams and 70 grams. And then from here, to figure out what ratio of nitrogen it is, you can divide by the molar mass of the substance, 14 and 16. Last thing to do is divide by the smallest number out of your numbers, and that will get you your ratio, N1O2. All right, see what you can do on these problems.